it's Cliff here from Down Under, another episode of RapidTurn. I'm just finished grinding my Arbor, 5C Arbor, to suit the new RapidTurn. I sent them a link to the last video, Tormach a link to the last video, in the hope that they might send me a replacement Arbor, but I guess they didn't want to establish a precedent or something, I don't know, but they didn't mention any such offer. So I've just gone ahead and ground this one back down to the size, to the spec size. This video actually is not much about RapidTurn, it's more about precision machining, and I go into two different methods of precision machining. Cylindrical grinding, and if you don't have a cylindrical grinder, lapping or polishing in a lathe. So if you're only looking for RapidTurn, you might want to skip this video. Alright, cheers. Abrasive paper or cloth is one way to polish down diameters, and another way for other applications or situations is stones. Mold makers' stones, there's a big range of different types of stones. Soft stones that are fine and have a soft bond that break down to the form, and you can break a stone down to the form of the part, the diameter of the part, for example, and that will give a beautiful finish, especially if the RPM is low and you're traversing the stone longitudinally to give a lovely cross-hatched finish. You can use stones mounted on V-blocks for polishing long diameter parts. There's all sorts of ways of polishing with stones. That's another whole subject. Perhaps I'll leave that one alone at this stage. I'm sure many of you know that machining to extremely high tolerances in a lathe with conventional tooling is pretty difficult. You know, you can turn down to within a thou, maybe half a thou, but to get much more accurate than that, you need diamond lapped carbide or high-speed steel tooling, and even then it's difficult to get a really good surface finish and a diameter down to extremely fine tolerances, you know, to within a tenth of a thou or a micron. That is pretty difficult. Usually you turn the part down to within about plus half a thou or plus a hundredth of a millimeter, maybe half a hundredth of a millimeter if you're going really well, and then polish the last few microns or lap the last few microns off. So for example, in this case, a 5C Arbor for an ER20 collet, it's been turned down to about half hundredth too big, so it's just a little bit tight in the 5C bore, and I'll just lap it down now with some wet and dry paper. I'll just show you that procedure briefly. I've found that about 400 grit waterproof paper, that's waterproof paper with fine aluminium oxide abrasive on it, is about right for general purpose functional fits where you're not worried about a extreme mirror finish. You just want to cut quickly, an accurate fit. So, and a ground parallel or a ground ruler, and you can just lightly score the surface to put a crease in it. And then if you have an old pair of scissors, because you don't want to use your good scissors, it's a bit hard on them, cut a piece about twice the width, and then with the score in the middle it'll fold really easily. It's a good idea to have it folded in half like that down the length, and that way when you put it against your ground parallel, it's got a little bit of thickness to it, and that gives it a bit of compression when you're lapping the diameter, and that helps it to cut more quickly, helps the abrasive particles to bite into the work better than if it's just one thickness. Okay, let's just show you briefly how I would lap a tenth of a thou off that diameter, a couple of microns. So put a bit of kerosene on the paper, and that's really important. Stop it from glazing up and keep it cutting smoothly. Just run it at a fairly slow speed and just with light pressure. Unfortunately there's a keyway in there which will give a little bit of a depression. Just press reasonably hard and keep it moving. And after half a minute you might have taken off about a micron. Okay, so we wipe off the metal particles. See that there, and it's a bit awkward working around the camera, but I'm just trying to give you the general idea. I know this will be very familiar to many of you, so forgive me for stating the obvious, but there may be some people here that will learn one or two tricks. So now we measure it again. Now, excuse me, obviously temperature is really critical here. If it's warmed up slightly from the light or from the friction, it will have increased slightly in diameter, maybe by a micron or two. So you may need to take that into account. So always feel the temperature of the part before you measure it. And I can see that's just come down, probably only about a micron. I'll take it out now and check it in RapidTurn, see how the fit is. So that's a nice snug fit now, just really close. So that's a little 5C to ER20 arbor that I've just made up, which will be really useful for gripping small diameter parts in RapidTurn. Because the good thing about the ER collets, unlike the 5C, is that they close over a range of a millimeter and a sort of parallel closure system, so that you can hold odd sizes within the complete range and not just standard sizes. So that's a lovely close fit now. And doing that is a way of gauging a close location fit. As you can see there, that's 31.754. Compare that with a fit of a low cost, with the diameter of a low cost collet. Bit of an art talking and getting it in the right place in front of the camera at the same time. So you can see there, we're looking at about 1.5 hundredths under spec. So we are 31.735. So that's going to be quite loose. We still focused on there, yep. So by comparison, you can see there's about nearly 2/100ths of a millimeter clearance there on the diameter, but that's only 1/100th of a millimeter per side location, and it's still reasonably accurate, still good enough for most jobs. You don't want to get too carried away with accuracy. I'm just sort of trying to show some of the principles there. Of course, I'd normally do precision machining like that in a cylindrical grinder, but I just wanted to show you folk that probably don't all have cylindrical grinders sitting in your shop, and I'm lucky enough to have an beautiful old Brown and Sharp that I can do jobs like that to extremely high tolerances. So here I'm grinding down the Arbor, the sleeve that I've had to shrink on the original Arbor of my original RapidTurn, which has got about 10 thou, from memory it was 10 thou, wasn't it? 0.25 bigger in diameter here to take up the error in my first RapidTurn. So now I'm grinding that back down to that same precision location fit as the ER Arbor I've just been showing you. Well, it's so much easier on a cylindrical grinder. You can remove tiny amounts of material and the temperature is controlled with the coolant. These old Brown & Sharps have got a clutch, and you can just turn, stop them, take a measurement, put on the final cut. If you're interested in cylindrical grinders, I've done a separate video on the subject. They have a separate table sitting on top of the main longitudinal slide that pivoted in the middle, and you can adjust for parallelness or taper through this very fine adjustment mechanism here. So the whole table twists on top of the slideway to give you very accurate adjustment of taper or parallelness. 5C taper is 10 degrees, and unfortunately the Brown & Sharp really only goes to 7 degrees, so I've had to kind of crib it 3 degrees further, which has brought the wheel spindle bearings too close to the tailstock, so I've had to take the tailstock out and re-clock the end to run true. I've got it running true within a micron or so, so I can just kiss that taper, because it had a little bit of a flicker in it, showing that the arbor had distorted over time, probably because it's induction hardened 1045 steel, which can let go when it ages. So just screwing that up to not perfect, but a bit closer than it was. There we are, all finished ground. Seems to be quite a nice snug fit. Quite pleased with that. Got to align it pretty carefully to get it in. Just a nice snug fit. Good. Well, that about wraps it up. A short video on precision machining of the RapidTurn Arbor and 5C collet adapter. Thanks for watching, guys. Some of you will be following the Hallmark Impact Tolerant Touch Probe progress. Just got good news on that so far. Shipped several out to the early adopters, and they've been going really well. Only had good feedback so far. It's probably a bit early yet to start putting together big quantities and shipping them out. So thanks for your patience and your support, and I'll keep you posted as to progress on that front as well. Cheers.